Welcome to our presentation of linking sensitive data. My name is Christen, and this work is done together with my colleagues Tilena and Rainer, where Tilena is also from the Australian National University and Rainer is from the University of Duisburg-Essen. In this talk, we're going to give a high-level overview of the applications, techniques and challenges of linking sensitive data. As you all know, linking data is an increasingly important application which requires records from different databases to be linked, where these records come from databases which are often owned by different organizations. It's an increasingly important topic in many domains, starting from the health domain to national security, national censuses, the social sciences, as well as crime and fraud detection. Due to privacy and confidentiality concerns, however, organizations are often not willing or allowed to share or reveal their sensitive data. There's many different privacy regulations in different countries across the world, and that makes it difficult to link data which is about people. Privacy-preserving record linkage, or PPRL as it's commonly known, is a set of techniques which are being developed mostly by computer scientists and statisticians and people in the health domain, where the aim is to perform linking of different databases that contain sensitive information by using encoded or encrypted values. So that means that no sensitive data has to be exchanged between the organizations which are involved in a linking. The outcome of a PPR project is only the set of matched record pairs where no information about any sensitive data from the input databases can be learned. The linkage process is completely secure and no external party can learn anything. So let's have a look at a few examples. Linking data newborn is an important aspect because the survival rate of newborns' perinatal health is an important indicator of the quality of a health system across countries. And so therefore we might have to use measurements of newborns, such as their weight, their survival, birth record information, death record information, information about the mothers, and so on. So this is highly sensitive information, and potentially in order to generate a database which covers a whole country, we might have to link sensitive maternity data with administrative data across hundreds of hospitals. Another application is linking census data over time. In many countries, censuses are conducted on a regular basis, and in order to create longitudinal data about the population, data which shows the changes over time, we need to be able to link records about individuals over time. And that requires basically that we have to keep, potentially, personal details such as names and addresses, and of course the challenge is then also that data such as addresses and names are changing. The public is generally concerned about what information the government is storing about them, and therefore it would be ideal if you can store only encrypted or encoded data, such that the data of the people is secure. So privacy-preserving record linkage, as quickly introduced before, is basically running record linkage on encrypted or encoded quasi-identifying values. Right? So we somehow have to encrypt or encode names, addresses, dates of birth in such a way that we still can do approximate matching. We can allow the linking of very large databases, so scalability is important, and we can provide the privacy protection. Ideally, we are able to evaluate how secure a PPRL technique is. So generally, PPRL techniques can be categorized into secure multi-party computation and perturbation-based techniques, where the first type of techniques, SMC-based techniques, are provably secure because they basically use advanced encryption techniques. However, these often come with high computational and communication requirements. On the other hand, perturbation-based techniques, they apply some form of encoding, often based on some form of hashing. They allow approximate matching, they're much more efficient generally, but they are potentially vulnerable to some privacy attacks. So let's have a look at perturbation-based techniques in a bit more detail. Techniques such as Bloomfield Encoding have shown to be very popular because they are efficient, easy to implement. They allow the comparison of textual numerical values and even hierarchical codes such as occupational disease codes. Because they're easy to implement, they're now being used in several real linkage applications worldwide. However, recent research has shown that Bloomfield encoding can be vulnerable to certain cryptanalysis attacks. So basically, Bloomfields are bit arrays, and so an attacker can identify certain patterns of 0 and 1 values in these bit arrays, and this pattern then basically allow the attacker, the adversary, to identify which frequent pattern correspond potentially to which frequent name. And that's of course not something which we want to allow if you want to link sensitive data across different organizations. So one big aspect, one big challenge is how do we evaluate privacy-preserving record linkage techniques. Generally, in non-privacy preserving linkage situations, we only have to evaluate the scalability and most importantly linkage quality. So for linkage quality, we have a whole range of quality measures such as precision, recall, sensitivity, positive predictive value, and so on. So these measure how the quality of the linked data sets. Scalability measures are things such as reduction ratio, so how many record pairs have been compared, of course runtime, memory usage, and so on. So they tell us how scalable a linkage approach is. Evaluating privacy is much more challenging. There is currently no single measure for privacy. Privacy is a very complex concept, and in different areas there's different ways of how privacy can be assessed. So measures from statistical disclosure control or information gain, so the information theory-based measures have been adapted to measure privacy, and more recent work is looking at vulnerability assessment. So how vulnerable are certain names or certain addresses or certain substrings in databases, and how vulnerable are certain encodings. So this is ongoing research. Besides these more conceptual aspects of how we evaluate the privacy-preserving linkage project, so privacy, linkage quality and scalability, there's a whole range of practical aspects which have to be considered. They will be important, right? And here we have a list of some of those. There certainly are more. So for example, we have to look at the legal constraints and the organizational implementations. So each linkage project, each linkage unit is conducted within the legal framework in their jurisdiction. Real-world data often is dirty and we have missing values. So we have to deal with those. How do we deal with missing values in quasi-identifiers? We also have the aspect of temporal and dynamic data. We mentioned this before. People change their names and their addresses over time. So how do we deal this in linking sensitive data? Once we have linked data, we have to deal with bias and uncertainty. And again, this work being conducted in this area. Of course, it's more difficult to identify bias and uncertainty if we work on encoded data. The whole aspect of cost of false and mismatches, it needs to be considered. Again, this is difficult because we potentially don't know what a true match is and what a false match is. So the lack of ground truth data and how we evaluate linkage quality in a privacy-preserving record linkage context is a challenging and so far not solved problem. Then the practical aspect of which privacy-preserving linkage techniques are suitable for a given linkage scenario. So some of the secure multi-party computation techniques require many communication steps, which might not be possible. Then the actual linkage scenario is of importance. What's the threat scenario? Is the data going to be linked within a secure environment? Does the data have to be sent across different channels? What is the technical availability in an organization? So does an organization have people knowledgeable in PPRL, in data linkage and in cryptography? And the last one is, what kind of software is there available? How hard is it to implement certain techniques? And again, many of the PPRL techniques only available in prototype software. So this was really a very brief presentation about PPRL techniques, how we link sensitive data. The good thing is that these techniques are now becoming mature, and the first practical applications are now being run in practice. There's however various practical aspects that are still hindering the use of PPRL, which we discussed, such as the formal legal constraints, the evaluation of privacy measures, the lack of ground truth data evaluation frameworks, the lack of high quality software, and the lack also of people with required expertise. So to basically provide an overview of this, we like to advertise our book, Linking Sensitive Data, which covers this whole topic in much more detail. It's going to be available in the next few months, and we hope this will be a valuable contribution to this topic of linking sensitive data.